right? Question 1f, function fx is equal to this plus this. Okay, so okay, you see, this is a modulus function. This is also a modulus function. Okay, so we have the sum of two modulus function, and we know modulus function is piecewise. So when you try to sum two piecewise function together, of course you end up with a piecewise function. So you know your fx, right, can be written in something like this with the condition. But we have to figure out what is the expression in the condition. So before we go to that, look at the modulus function separately, individually like this. Okay, so modulus x minus 1 can be equal to itself or the negative of it. This one also itself or the negative of it. Okay, then we write down the condition. Greater than equal or less than, greater than equal or less than. Okay, then we have to write out the value here. So I show you how do we get the value from here. This one is 1. It's 1. Okay, how to get the 1? So you draw the line. You draw the line of x minus 1 like this. Okay, and then we know that when you modulus it, then the negative part go to positive. So all this negative part here, you go to positive like this. And here no more. Okay, then your graph become a V shape. So this graph, the point of reflection is starting from here, right? This is the point of reflection. And what is the value of it? 1, right? So you write down the 1 here. So it's the point of the reflection happen. Okay, so for x minus 2, if you draw the graph, you will see that actually the reflection happened at x equal to 2. Okay, yeah, then we have something like this. So up to here, okay? Right. Then here we want the sum. We want to plus them together. Plus. Okay, don't ask me why we plus together here, because we are trying to sum up the two functions together. Okay, so here plus. Okay, to plus the two piecewise function together, we have different cases because it's possible to have like this plus with this. Okay, you can have this plus with this as well, right? Yeah, so we have to consider all the case lah. So we start with case number 1. Okay, case number 1, this plus with this. So x minus 1 plus x minus 2, 2x minus 3. The condition is x greater than equal to 1, x greater than equal to 2. And we want them to happen together because we want to plus them together. So you have to make sure they happen at the same times. So, and D. So this and this, what is the result? X greater than equal to 2. Yeah. If you can't see it, then you draw the line. You draw the number line like this. X greater than equal to 1. So a solid circle to the right. Solid circle to the right. So the overlapping is here. Yep. This is how we get the x greater than equal to 2. So from here, done with one case, case 1.
I'm sorry, why can't we input all the cases to one line?
In all the cases to one line?
Yes.
How?
Like take all the x equal or more than 2 or at least is less than 2 and draw all of them in one line.
Do you have an example? You can write down.
Like take all of these cases and draw them in one line, you know? Yes, like we input here 1 and 2, and then we see this case, it's like x, yes. So we go here,
Okay.
and then we have, no, yep.
Uh,
No, we cannot.
okay. So yeah, case one, case two. Case two, we take this one plus with this. Okay. So x minus 1 plus 2 minus x. So you have a 1. So the condition is greater than equal to 1 and less than 2. Then you draw out the things 1, 2, greater than equal to 1 solid circle, less than 2, so empty circle, then the overlapping. So yeah, from here, know that the result should be x between the 1 and 2 lah. Yeah. So 1, 2. Okay. Okay. Then go to case number 3. For case 3, I use this plus this. Okay, this plus this. Sorry, this plus this. Right, 1 minus x with the x minus 2. Okay, so 1 minus x plus x minus 2. So you have a negative 1. The condition is this. So if you draw it out, 1, 2, less than 1, more than equal to 2. From here, you can see that there's no overlapping. No overlapping, which means they can't happen together lah. So this case is not possible. It's not possible to happen. Okay, no overlapping. Then you go to the case 4, the last case. Case 4, look at this and this. Okay, 1 minus x and 2 minus x. So you have 3 minus 2x. The condition is less than 1, less than 2. And so if you look at the number line, empty circle, and the overlapping is here. So x less than 1. Yep, so this is the 4 cases. So with all these cases here, we know case 3 is not possible. So from the rest of the 3 cases, you can write into a function notation. Okay. So we're going to have a fx equal to piecewise function 3 minus 2x when x is less than 1 from case number 4. Okay. Then case number 2, is equal to 1 when x is between 1 to 2. Then case 1, 2x minus 3 when x is greater than equal to 2. Like this. And now with this expression, we can sketch a graph already. But before that, we talk about domain. So the domain for this function, right, is all real number, because you see it can be less than 1, the left hand side of the 1, between 1 and 2, okay, more than equal to 2. So basically everything's all real number. Okay. Okay, then we want to sketch a graph. You want to sketch a graph, you have to analyze the expression here a little bit. So 3 minus 2x, you have a y equal to 1, you have a y equal to 2x minus 3. Okay, so yeah, before you sketch a graph, you look at the things you already know is a linear graph. It's a straight line. So this one is going down, this one is horizontal, this one is going up. Okay, and with a certain condition that I want to restrict it for within that interval. Okay, so we draw the things one by one. X-axis, y-axis, 0. Okay, y equal to 3 minus 2x. This is true when x is less than 1. So when x equal to 1, because we need to have the starting point, so-called the ending point, starting point. So when x equal to 1, your y is equal to 1 as well. So you have a point 1, 1. And no equal sign, so you use the empty circle and to the left. So this is 3, because the y-intercept is 3. So to the left. Okay, so this is the first part of the graph. Right? Y equal to 3 minus 2x. Then go to the second graph here. This one. A horizontal line between 1 to 2. So it can be equal to 1. So this value here is going to be, now I'm going to draw a solid circle to the right, and then empty circle, then 2. So this is y equal to 1. The second part of the graph. Then the last part of the graph, y equal to 2x minus 3. X start from 2, so I substitute. When x equal to 2, your y is equal to 1, so 2, 1. And it can be equal to 2. So again, solid circle here, then you go up. Make sure it's a straight line. Like this. Okay, so this is y equal to 2x minus 3. Then you have the graph radio. So you combine everything together, it's a graph of this, x minus 1 plus x minus 2. So what is the range? What is the y value that you can take here? Y greater than equal to 1. Yep, greater than equal to 1. Okay, any question? Yeah. Sleepy.
Excuse me, can I go?
Ah. What time your class today morning? 8 o'clock. 10. Okay. Okay, so I show an easier method. For this one, we have two methods. the case 1 to case 4. This is algebra method, you do a calculation and all that. We have another method called graphical method. I can actually get all these condition here, all these things, right, by looking at the graph. Okay, so okay, look at the graph here. The modulus x minus 1 and modulus x minus 2 lah. Okay, if you don't want to split into 4 cases, right, you can sketch a graph of the two linear function, the two modulus linear function on the same axis. Then we analyze from here. Okay, so yeah, first of all, you have to know that this is x minus 2. Label all the expression first lah. This is 2 minus x. This is 1 minus x. Okay, we label first. And then we look at the point where the reflection happened. The reflection happened here and here, right? So I will separate the region of the graph vertically like this. Okay, then your graph become 3 region. First region, second region, third region. Okay, and yeah, by doing so, right, then I can make sure in each of the region, the expression of the line stay the same. It won't be like suddenly 2 minus x, then suddenly become x minus 2. No. Okay, this is the reason why I want to split it like this lah, according to the reflection point. Okay, now we look at the first interval. This first interval happened when x less than 1, right? X less than 1, all this. Okay, plus them together because we want to plus them. So plus together. When you plus together, 3 minus 2x. And it happened when x less than 1. Okay, then we come to the second region. Okay, what is the expression of this? 2 minus x, right? Okay, the expression of this, x minus 1. So when you plus them together, 1. And the condition is between 1 to 2. Okay, then you go to the next interval, the third interval here. Plus them together, 2x minus 3. And this happens when x is greater than equal to. Then you have all the expression already lah. Expression and the condition. So yeah, from this graph here, then you can jump directly into this step here, the function. Yeah, by looking at this, right? Yeah, then you can write out the function notation, you sketch a graph, find the range. This is graphical method lah. And I think you don't know how to sketch these two graphs together, right? It should be very easy because it's a very simple modulus function. So yeah, can use this method lah if you found that this is more efficient. So yeah. Okay. Yep. Any other question? No. I think the rest we haven't covered yet because we haven't go through the lecture class this week. So the rest we will leave it for next week lah. After lecture class, you can try the rest of the question and also the tutorial 1. We have a tutorial 1 uploaded under week 3.